What if energy no longer came only from distant power plants, but from the world around us? Buildings, roads, vehicles, clothing, and devices could harvest, store, trade, and route power, creating a programmable energy fabric for the next era of infrastructure. So far, we've built a stack: autonomous intelligence, spatial interfaces, biosystems, robotics, and programmable materials. Project 24 brings those threads together. Now the focus turns to energy as an intelligent fabric, where buildings, devices, storage, and infrastructure coordinate as one adaptive city-scale system. The future energy system may look less like a one-way power grid and more like the internet. Buildings, roads, vehicles, devices, and even wearables can generate, store, route, or trade small amounts of energy. I at the edge coordinates those decisions in real time. Instead of data packets moving through networks, watts and storage capacity move through everyday infrastructure. At the system level, the built environment starts to behave like an energy organism. Surfaces that harvest power become producers: roofs, windows, roads, walls, and moving structures. Energy is stored locally in buildings, vehicles, batteries, and devices. A routing layer then decides where electrons should flow, using inverters, microgrids, and edge controllers. Above that, AI agents forecast demand, price flexibility, negotiate trades, and protect resilience. The key idea is integration: generation, storage, routing, and intelligence working together. The first building block is turning everyday surfaces into small power plants. Flexible photovoltaics move energy collection beyond rooftop panels and into windows, facades, vehicles, tents, and fabrics. Newer perovskite and organic cells matter because they can be lightweight, printable, curved, and partly transparent. Sunlight is only one source. Piezoelectric and triboelectric materials capture pressure, steps, vibration, and friction from roads, floors, shoes, or machinery. Thermoelectrics capture wasted heat from buildings, engines, factories, and even bodies. Together, these materials make generation distributed, continuous, and embedded into the environment. A resilient energy fabric cannot depend on one giant battery at the edge of the grid. Graphene-enhanced batteries and advanced carbon storage could charge faster, last longer, and handle heat more safely. But the bigger shift is distribution. Storage moves into buildings, vehicles, facades, and local backup systems. Electric cars become more than transportation. They become mobile energy reserves. Supercapacitors handle quick bursts, while structural storage holds energy in the built environment. These small reservoirs reduce peak demand and keep critical power available during outages, heat waves, or emergencies. Energy also becomes more mobile. It is no longer tied to one fixed outlet or one fixed direction. Solar surfaces and batteries create supply, smart inverters convert it into the right form, and routing software decides the best next step. Power might charge a wearable, top up a drone, support a robot, or move into a vehicle through road-embedded charging. If local demand is low, it can be stored, shared with a microgrid, or sold back. The fabric becomes active because energy can move where value is highest. Demand response begins with awareness. Sensors monitor rooftop generation, battery state, appliance load, occupancy, temperature, weather, and equipment health. Edge computing turns those signals into local predictions without waiting for the cloud. If demand is about to spike, the system optimizes flexible loads first. It may pre-cool a building, delay EV charging, shift a factory cycle, or change appliance timing. The goal is to move energy use to moments when the grid can handle it, while preserving comfort and productivity. Because these patterns reveal daily routines, privacy has to be designed in from the start. AI grid agents act as energy coordinators at different scales. A device may decide when to charge. A home agent balances comfort, cost, and backup power. Building and neighborhood agents coordinate solar, batteries, and flexible loads so the local grid stays stable. At the city level, agents combine forecasts for weather, traffic, demand, and infrastructure stress. The shift is from one central controller to many local decisions, constantly negotiating whether to buy, store, share, reduce, or protect energy use. Decentralized ledgers add a trust layer to local energy markets. A home, EV building, or public battery can exchange power physically, while the ledger records who produced it, who used it, what price applied, and when settlement occurred. Smart contracts make the rules executable. They can adjust payment using location, time, congestion, carbon intensity, or available storage. Provenance matters because not every kilowatt has the same value. Solar, stored energy, and vehicle discharge may earn different credits. Once energy rights are tokenized, markets can trade not only electricity but flexibility, resilience, and grid services. The programmable energy fabric works because each component closes the loop. Energy-generating surfaces and devices supply local needs first, with excess flowing into batteries, vehicles, or building systems. Edge sensors track what is being produced, stored, consumed, and stressed. I decides the best action, balancing cost, comfort, resilience, emissions, and grid conditions. Distributed ledgers make exchange trustworthy across homes, fleets, appliances, and infrastructure. Demand response then adjusts loads, shifting or reducing consumption, so the next cycle begins from a smarter state. Imagine daily life in 2050. Your home makes power from the roof, windows, and walls, then stores extra energy locally. During the afternoon, EV fleets charge when solar is abundant. In the evening, those same batteries can support homes and public buildings. Streets, lights, and sidewalks become active energy assets. The key is coordination. Neighborhood AI balances comfort, cost, carbon, and resilience, so the community behaves less like separate customers and more like one intelligent energy system. Programmable energy fabric is not one startup category. It is a venture stack. Some founders will win at the material layer with coatings, glass, skins, batteries, and sensing surfaces. Others will build platforms, the operating systems that coordinate buildings, fleets, campuses, factories, and cities. A third group will create markets, turning flexibility, resilience, carbon timing, and peer-to-peer exchange into tradable value. Some will package infrastructure as a service, from microgrids to storage networks and vehicle grid orchestration. The key design question is where your company captures control: the physical asset, the data layer, the transaction layer, or the network relationship. By 2050, the biggest change may be that energy is no longer something delivered from far away. It becomes part of the city itself. Rooftops, vehicles, batteries, buildings, and neighborhood microgrids all produce, store, and trade power. That makes the system more resilient, because failure in one place does not shut down everything. It can also lower emissions when these assets coordinate around renewable supply. But the future is not automatically fair. The key design question is ownership. Who controls the energy fabric, who can access it, and who shares in the value? The big takeaway is that energy can become a programmable fabric, not just a one-way utility. Flexible materials, storage, inverters, wireless transfer, edge sensing, AI, and decentralized markets work together so every surface and device can participate. That unlocks more resilient cities, cleaner infrastructure, and greater local autonomy. Next, we extend this logic toward climate repair and carbon mineralization.